All right, so this video is basically going to be the live session for day 8 assignment in Delta Math. For those of you that do not have, for you B-Day students, you do not have a live session because it's asynchronous day only because of the SAT test. So you can use this video as the live session. Basically, I'm just going to go over the day 8 assignment in Delta Math. Now, just to remind you, you see that you do have these assignments day 1, day 2, 3, and day 6 in the late credit. You can still work on those. You can bring those up to a grade of 99% if you want to improve your grade, okay? You still have access to those, okay? But let's look at day 8. The first two, visual domain and range, that's complete review from months ago. You should be okay with that. But I do want to look at some of this that was previous to spring break, all right? So find growth and decay percentages. Let's go ahead and take a look at this one. Given the following exponential function, identify whether this represents growth or decay. Okay, in order to identify growth or decay, we're going to be looking primarily at what is inside the parentheses. Okay, the number inside the parentheses. If it's greater than 1, then it's growth. If it's less than 1, then it is decay. All right, now you will see that this number is 1.05. So it is going to be growth. All right, but what is the percentage of growth? Well, taking a look at the decimal, it's 1.05. Now, the 1 is just what identifies that it's growth, because we're going to multiply 10 times the original value, or 10 times 1, which stays 10, but then the 0.05 is going to be that decimal that changes it. Okay, but we have to convert 0.05 into a decimal, or into a percentage. The way that we do that is we move the decimal 2 places to the right. And that would be 1, 2, and it would be 5%. That is a bit of a review, but you should understand how to convert a decimal to a percentage, and that's a 5% increase based on what's inside this parentheses, and that's growth. All right, so let's move on to the next question. So that's finding growth and decay. All right. Well, maybe we have another one. Let's see if I can go to the next problem. I don't know if I can or not. I really can't. But basically, if something inside the decimal is less than 1, then it's going to be a decay, but you need to work out how to find it as decay. All right, let's move on. Let's use this table to determine the function. Okay, so it is exponential. Okay, it's an exponential function. We know that by looking here at our outputs. We're going from 4 to 2 and 2 to 1 and 1 to a half. Basically, what we're doing is we're actually multiplying by 1/2. Okay, multiplying by 1/2 every time. 4 times a half is 2. 2 times a half is 1, and 1 times a half is 0.5. Okay, so inside our parentheses is going to be half, or 0.5. We could use it as a decimal. Half as a decimal is 0.5. All right. But we also always want to look at where we're starting. And we're starting at 4 because when x is 0, y is 4. So our equation, y equals 4. And then in parentheses, 0.5, or we could just put 0.5. But 0.5, and then close parentheses, and then to the exponent of x. Okay, exponent of. Sorry, my handwriting looks a little sloppy. I'm using a new program where I use paint on the screen, but I'm using my cursor. So anyways, that's a 4. So 4 times 0.5 to the exponent is how that one would work. All right, next question. Linear, quadratic, or exponential. Okay, let me erase all that. So when you're given a table and you're trying to determine if it's either a linear or an exponential or a quadratic or not a function. This is how you do that. So we started out with linear. If it was linear, then what we have is a common difference of the outputs, okay? Now let's look at this one. It looks like this one may actually be, all right, so, what did I do? All right, so if we go from -2 to -1, what we've done is we've added 1. To go from -1 to 0, we also add 1. And it looks like we're adding 1 every time, okay? Well, if you have a common difference in your outputs, as long as your inputs are different, like 1, 2, 3, 4, 5, we don't have anything repeating, so we have a function. This one is going to be linear because you have that common difference in your first difference in the outputs, +1, +1, +1. That's a linear function, okay? All right, let me go back. So that's how that works. It's either going to be linear, quadratic, or exponential, okay? I could create you, let me pause for you. So if you have trouble determining if it's linear, quadratic, or exponential, I'll post some notes, kind of a note page to the Day 8 module that will show that, okay? But let's move on to the next type of question. So here's a domain of exponential functions. Well, that's a video for you to watch. Let's take a look at this question. All right, so if it's asking about the domain, okay, remember that we're talking about the x-axis. You have to remember that part of domain. So the domain is everything on the x-axis, okay? Now, notice that we have an arrow here pointing to the left, and we have this arrow up here. This arrow is going up, but it's also going to the right. So it's going to go on forever to the right, and it's going to go on forever to the left. So if we're talking about domain in this specific example, all right, we would be looking at all real numbers because it includes everything to the left and everything to the right, all right? Now, if it's asking about the range, all right, so this one is a little different. It's the same graph, all right, but it is asking about the range, okay? The range is the y-axis, and I can't obviously draw a straight line, so let me use this. It's the y-axis, straight up and down, okay? So we're looking for what is the lowest number and what is the highest number that's included, all right? Well, again, you see the arrow here, so it's going to be everything that's going to go up, and that's not going to stop, okay? But notice that it doesn't go below this line right here. Remember, this is called the horizontal asymptote, okay? This dotted line right here is at when y is -1, okay? This graph is never going to cross that. It's the asymptote. Also, it's listed, you'll see it in the function up here, y -1. All right, so your y is always going to be greater than -1 in this specific question. The range never goes below -1. It's always more than -1. This is the asymptote right here, okay? All right, next question. I'm going to erase everything. All right, so that was range. Now let's just look at some, these last three questions are very similar. It gives you a function that you can go in and graph into, in Desmos. And if you graph it in Desmos, you can look at your graph, you can look at the table, and you can identify which one of these graphs represents this function. And then you can answer the question, what is the horizontal asymptote? And you can find whether the function is growth or decay, and then if you know an x value, you should be able to determine a y value, okay? That's what this assignment, these last few questions are about, okay? So let's go ahead and do that. Let's go graph this in the Desmos graphing calculator. All right, so if we graph that function in Desmos, it's y equals, by the way, I'm just going to write this as y equals 2 times 3 to the x minus 4. So we enter that as y equals 2 times 3 to the x and then minus 4, and it graphs it for me so I can see it here. All right, then you want to grab a table, and it gives you a table of values. So you know when x is 0, it's at -2, so it starts at -2. When x is 1, and so on. When x is 1, y is 2, or when x is 2, y is 14. We can see that on our graph. So then we'll go back over here to answer this question. All right. And which one of those? First of all, they're all at 0, -2. 0, -2 is here. And it's here. And it's on all 4. Okay. So then let's go check and see what the value of 1 is on all of these. And again, if we go back, 1 is supposed to have a value of 2. So we see here that 1 does not have a value of 2 on answer A. The input of 1 does not have a value of 2 in answer C. And 1 has a value of 4 in answer B. And finally, 1, here is 1, 2 on answer D. So it's most likely answer D. We could also look at 2. Remember, when we have an input of 2, we have an output of 14. So yes, it looks like 214 is right here. Okay, so it's going to be answer D. All right, so we scroll here, we just select D. Okay, and then the horizontal asymptote. Well, again, that's that line that it is approaching. Okay, here. Sorry, it's that line that it's approaching. It's dashed line, and it's when y is -4, it looks like. -4, remember it's also here. All right, so when y equals -4, okay? And this function represents, well, does it represent growth or decay? Well, remember, we read from left to right. And if the graph is going uphill, which the one we chose, answer D, is going uphill, all of them are, but it means it's growth. Okay? And then the following coordinate pair is a point on the graph, fill in the missing value when x is 3. Well, you probably can't see what 3 is on any of these. Here's one you might be able to see, but remember, our answer is D, so we go over here to 3, we can't see it, but we could use our graph. So over here, we could just come over to the table and enter a 3, and it tells us that it is 50. All right, so again, when x is 3, the output is 50. Now you could have worked that out. You could have gone up here and put in a 3 for the exponent and worked it out, but we know that it is 50. Okay, and that's how you answer those. All right, now. The last 2 questions, I'm only going to go over one other thing that would be helpful. It asks one additional question. And I know I got a lot going on here with the ink. The last of this question, what does the initial amount start? Or what does it mean? So in this question, we have, it says Jana started off with an initial amount of $4. Well, anytime it says you started off, okay, that's going to be when the days or the beginning, when we start at 0, the y-intercept is going to be 4. So the 4 represents the y-intercept, okay? All right, that's a video I just made and trying to use some of that ink. Hopefully this was helpful if you needed it, but just complete that day 8 assignment. I know we don't have a live session. If you have any questions, you can email me, ask me, and I'll try to get back to you and help. So, but hopefully this was helpful.